after looking at constant functions and linear functions, we're going to move on to quadratic functions. A quadratic function is in the form y equals ax squared plus bx plus c, or using the function notation, f of x equals ax squared plus bx plus c. A, B, C are constants, and a cannot be 0, because if a is 0, then you get a linear function. Because if a is 0, then you will have 0 times x squared plus bx plus c. So that would give us bx plus c, which is a linear function. So that's why a cannot be 0. So some examples of quadratic functions are y equals 2x squared plus 4x plus 1. Or f of x equals negative x squared plus 3x plus 1. Next, we are going to see what the graph of a quadratic function looks like. It's in the shape of a parabola, and it's a curve. Parabola 拋物線. So we are going to look at the different parts of the graph of the quadratic function. So first of all, we have the graph on the left, and you can see the U shape. So the very bottom point, this point here, is called the vertex. V-E-R-T-E-X, vertex, and it's a point. And as you can see, the dotted line cuts the graph into two equal parts. So this dotted line is called the axis of symmetry. And as mentioned before, C is the y-intercept. So that's why this is the y-intercept right there on the y-axis. On the right, we have another quadratic function, the graph of a quadratic function. It's also in the shape of a parabola, so it's the U shape, but it's opening downwards, facing down. So this time we have the point which is on the very top. This point is also called the vertex. So the vertex could be the point on the very top if the graph is opening downwards like this upside down U shape. Or the vertex could be the lowest point, which is the U shape on the left. So we have a point that is called the vertex. The dotted line cuts the graph into two equal parts. So this dotted line is called the axis of symmetry. Okay, so you might want to ask, how do I know if the graph is opening upwards or downwards? If the graph is opening upwards, then a is greater than 0. If the graph is opening downwards, then a is less than 0. So you look at the coefficient of x squared to help us to determine whether the graph is opening upwards or downwards. So let's look at the table that summarizes the features of the graph of quadratic functions. So we have talked about it. We have a symmetrical line. So the quadratic graph has reflectional symmetry about a vertical line, and this line is called the axis of symmetry. And we have a point which is called the vertex. Just now we talked about it. The graph could be opening upwards or downwards. So if A is greater than 0, the graph opens upwards. And the vertex would be the lowest point or the minimum point of the graph. Whereas just the opposite, if A is less than 0, the graph opens downwards, and this time the vertex would be the highest point, which is also the maximum point. Just now, we also have talked about the y-intercept. So the y-intercept of the graph would be C, which comes from here. This one is the y-intercept. And back in chapter 1, we have learned how to find the roots. And the roots of the graph would give us the, the x-intercepts of the graph would give us the roots. And in order to determine the number of x-intercepts, we look at the discriminant, we look at delta.